Hi guys, you have two assignments today that you're going to do. You are going to do the electron dot diagrams polyatomic ions number 1, and then on the back of that it's electron dot diagrams multiple central atoms. So I want to give you an example of the polyatomic ions. So let's look at a polyatomic ion, SO4. And it has a charge of -2. If you remember when we learned about those polyatomic ions and you have a whole sheet of them, sulfate was a -2 charge. So let's start by adding up the valence electrons just like we always do. Sulfur has 6 and oxygen also has 6, but we have 4 oxygens. So that's going to be 24 plus the 6, that would be 30. Now, the polyatomic ion has a -2 charge. So that means that there's 2 extra electrons. Remember, electrons have a negative charge, and so it gets that -2 charge by having 2 extra electrons. So this 30, we're going to add 2 to it, and so we have 32 total valence electrons that we want to try to put in our diagram. Okay, so basically from there, everything that you do is going to be the same as what you've learned so far. You're just going to try to fill the octets for everything and make it work out. So I'm going to put sulfur in the middle. Remember, we're always trying to keep things as somewhat symmetrical as we can. And then it's just a bit of trial and error from here. And so I'm going to try this and we'll see if it works. I usually do start by just trying to put 8 valence electrons on everything and see if I have too few or too many, and then go from there. Okay, so I've got 8 on this oxygen, and then plus 8 more on this oxygen, so that makes 32. 8 more on this oxygen, that makes 16. 8 plus 8 is 16. So 8 more on this one is going to be 24. And then 8 more on this one is going to make 32. And so that gets me the 32 valence electrons I need. And everybody, including this sulfur in the middle, has a full octet. And so that's how you would draw the Lewis structure for the polyatomic ion sulfate. So you're going to do like you did yesterday, where you have to do step 1, step 2, step 3. So this is what step 3 is going to, this is what step 2 is going to look like. Okay, I kind of got ahead of myself a little bit. Step 1, basically what you would do is you would draw sulfur with 6 valence electrons because it has 6, and you would draw oxygen with 6 valence electrons because it also has 6. If you want to draw 4 of those oxygens, then you can, but I'm only going to be looking for 1 of those oxygens. And then, actually, on that one, it doesn't even tell you to draw the valence electrons. In step 1, it actually only tells you to calculate the number. So in step 1, rather than drawing this like you did yesterday, I'm just going to ask you to calculate the number. So that would be our step 1. And then for step 3, we would draw the model, replacing the bonds with lines, okay? And so it would look like this, and then filling in our valence electrons on the oxygen. These type of models are going to be really important with what we are doing next week, which I'm sure you all are excited to be back in class next week on an AB schedule. So I'm excited to see you all again. And we're just really gearing up to know how to do these Lewis structures for what we're going to work on next week. So that's a polyatomic ion. Just making sure if it's a negative to add 2 more electrons, if it's a positive to take away the number of electrons as the charge. Okay? Now, the next one you have is a multiple central atom. Okay? And so for these, I think it's easiest to kind of go with what you're given, okay? And so go in the order. So on a lot of them you see CH2, CH2. And so those are kind of groups. CH2 is a group and then CH2 is a group. So you want them to kind of look grouped, so to speak, on your period or on your diagram. So let me give you another example. Let's do one. Let's do a molecule called pentane, okay? So pentane is C5H12. Or we would write it CH3, CH2, 3, CH3. Okay, that's the molecular formula of that. Okay, so when I draw this molecule, this pentane, I do it kind of like the groups say. I've got CH3, so I'm going to draw my CH3 there. Actually, I'm going to change these to dots for what I'm doing right now. Okay, and then I've got CH2, so I'm going to draw the CH2. And then it says I've got CH2 again. And I'm drawing these vertical here. It doesn't matter if you prefer to write them side by side like that, then you can. I don't really know why I did them vertical here. So CH2. So I've got 3 of those, so I need 1 more. And then CH3. So this shows multiple central atoms, okay? So I've got my first CH3 right here. I've got my 3 CH2s right here. And then I've got my last CH3 right here. Now, let's count up our valence electrons and make sure that we have the correct number of valence electrons, okay? So I have 1, 2, and then 3, 4, 5 carbons, okay? So I've got 5 carbons. Each of those has 4 valence electrons. So that's going to be 20 total valence electrons in carbon, okay? I have 3 hydrogens here, plus 3 hydrogens here. That's going to be 6 hydrogens, plus 2 times 3, 6 more hydrogens. So that gives me 3 plus 3 plus 6 is 12 hydrogens, okay? Now each of those has 1 valence electron, so I've got 12 total hydrogens, 12 total valence electrons from hydrogen. So total I have 32 valence electrons, okay? So this is a neutral model, meaning it doesn't have a charge, so I don't have to add or subtract any valence electrons there like I did in the previous example. So I just want to make sure that my diagram has 32 valence electrons. So count them with me: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay, so I think that I've got all of those valence electrons. All of my carbons have their octet full. Okay, I'm just kind of trying to sloppily show this. And then all of my hydrogens have their 2 valence electrons that they like to have. Nobody has more than 2. I'm not going to square the rest of them. Hopefully you get the idea. And so everything is happy and is the way that it needs to be. So what you see here is I have my multiple central atoms. So when I draw this one for step 3, I had 5 carbons with hydrogens all around. And this is a molecule called a hydrocarbon. It's a class of molecules. We'll talk about all of those a lot in regular biology, but this is a molecule called a hydrocarbon because it's made up of solely hydrogen and carbon, okay, single bonded together. It's also in a class of molecules called an alkane. Alkanes mean a carbon and a carbon connected with a single bond. So I'm not expecting you to know those things now, but those are things that we will talk about a lot when you all take AP Biology with me next year. Woohoo! Right? Everybody's going to sign up for that. So this would be what you would write in step 3. Okay. Step 2, you're going to, it would look like this. So this was step 2. And then step 1, it did ask you to draw the atoms separately. So in step 1, you would do like carbon with 4 on it, or however you choose to do 4 on it, and hydrogen with 1 on it. Okay. So that is how you do the back side of that assignment for today. So if you all have any questions, let me know. And if not, then you all have a great day.